Okay, good afternoon. Welcome back. You'll notice I got a little bit different recording procedure going on here. I've been getting techie, and now I figured out how to capture my screen without actually pointing an iPad at it, so we're going to hope that works a little bit better if you watch videos, and especially for our online students joining us here. Few things. We'll talk about the problem that you just did. We'll talk about the painting problem that I told you to come to class with for today, and then we got a couple other problems to tackle today. I put a new document. Go ahead and check this out on Blackboard. Course docs and links. And right underneath the 2.3 intro PowerPoint, it says, use this checklist rubric to assess yourself as you work on solving application problems. I'm going to open that up. You can take a peek at it if you want. I've said this a couple times, and I'm going to continue to say it. I want you to accomplish more in here than trying to become an equation solver. Okay? So when we work on these application problems, the painting problem, the banana problem, I'm going to show you some videos today, and those are going to elicit a math problem, and we're going to try to get creative and try to work through it. You should reference this document and ask yourself if you're doing these things. And if you're doing these things as you're working through a problem, then you're approaching it the right way. Now, are you going to hit every one of these check boxes on every application, real world word problem? No. Some of them just you'll skip over it. It'll be easier than what it says on there. Maybe you do something different. But just take a look at these. Understand the meaning of a problem. Look for entry points to its solution. Some of you, when you start on a problem, you can't even find an entry point. Like, how do I even get started? Right? That's a difficulty. But that means you just have to try something. Analyze the information that's given to you. Make a conjecture. Make a prediction. I think it's this way. I'm going to try it that way. And then notice the fourth box. Monitor and evaluate the progress and change course if necessary. Have you ever been working on something, you got halfway through it and said, oh, this isn't going to work. I totally screwed up this. And you had to start over? That's what that's all about. That's what doing mathematics is all about. Check your answer to your problem. Does this make sense? I'll give you an example. Hopefully you came with some kind of painting solution to the problem I gave you on Wednesday. I think it said Jamie can paint the garage in 12 hours. And Karen, that's my wife's name, Karen, can paint the garage in 8 hours. Is that correct? So, let's say you work this out, and the question is, how long will it take them to paint it if they're working together? And you came up with an answer of 10 hours. Anybody come up with 10 hours? Yeah? How did you do that?
I don't know. Let's see. I totally thought it was wrong.
Well, it is wrong. So, okay, now this is where this would come in. If it takes Jamie 12 hours to paint the garage, and it takes Karen 8 hours to paint the garage by herself, and Jamie 12 by himself, you might say, oh, the average is 10, right? Somebody tell me why that doesn't make sense.
Well, if it only took Karen 8, it's not going to take her more if she has help.
Correct, right? If Karen can do it by herself in 8 hours, and I come to help, is the time going to go up? No, it should go down if two people are working. So right away you should know my answer has to be less than 8. Right? So that's one of those, you got to think your way through and you got to work it, in your brain a little bit. Make sense of quantities and relationships. Represent abstract situations symbolically. Another way of saying that is if I don't know what something is, I'm going to call it X. And I'm going to try to solve for it. I'm going to use variables. Okay? Consider units being involved. Sometimes it's like, feet per second or something like that where you're trying to get your labels correct. Construct viable arguments. Make conjectures. Use counterexamples. Communicate. Defend your mathematical reasoning. Now, Bailey, before you even had a chance to defend your mathematical reasoning, I told you that it wasn't right. So you gave up on your defense at that point. But if I had more time, I would have let you give a defense. And it's okay if we argue something and it's not correct. That's what we do. The one I'm going to give you before we go home today, I sat and looked at it this morning, and I've seen the problem before. And I looked at it this morning, and I was solving it, and I'm like, oh, wait, that's not going to work. And I had to stop, and I had to go back to it. Okay? So please don't think that when you're in a math class, somehow the math professor is this brilliant mathematician that knows the answer to every single math problem. It's an 8th grade level problem, and I struggled with it this morning as I looked at it, and then I had to stop and I had to start over again. So if you feel that way, don't feel like you're inferior or something. That's just a natural problem-solving thing that we all go through. Apply prior knowledge, identify quantities, use assumptions, check to see if an answer makes sense, communicate precisely, use labels, use clear definitions. All of these are things that you should ask yourself if you're doing. If you're doing this, then you're a good math student. It's not just about the final answer. I guarantee you, the 2 items that we work on in class today, I would be shocked if somebody got the exact perfect final answer on either one of them, because there's going to be sources of error and it's just not going to come out perfect. Okay? So try to eliminate this perfection thing from your mind when we work on some of this. Okay, enough on that. I'm going to save the banana for later. Okay? I want to jump to the painting problem that we worked on. I worked it out. You should have worked something out. What I hope you did is you at least came up with something. You at least gave it a run. You at least tried to write down a formula. You tried to see if anything would work. Is anybody confident that you nailed it? You got it? How long is it going to take if the 2 people are working together? Did I see you raising your hand with confidence back there, Peyton? No? Anybody want to take a stab? I do have the answer. And there is an exact answer to this one. Okay? As opposed to the 2 I'm going to show you later. You want to say something over there, Luke? No? Somebody spit out an answer.
I can tell you what I got.
Go ahead.
Right. I did A times B divided by A plus C, or A plus B.
Okay, I don't know what you mean by A and B.
Oh, Jamie is
Yep.
A and Karen's B.
Okay.
So their times, so I did 8 times 20 divided by, or 8 times 12 divided by 20.
And what did you come up with?
4.8.
4.8? So 4.8 hours? That's the answer, by the way. Anybody else get 4.8 hours? Now, I'm not exactly sure that I followed what Luke was trying to tell me, but I did hear the correct answer at the end. So, now I didn't give you much of an opportunity. If I came up here and gave you the podium and you had 5 minutes to explain it to everybody, I bet you would explain it better than what you just did now. Okay? But Luke could take that checklist and he could ask himself, did I do all this? Did I attend to precision? Did I use my labels properly? Did I make an argument? Stuff like that. So you found out that 8 hours and 20 or 8 hours and 12 hours, and then did what?
I did 8 times 12.
Yep.
Divided by 8 plus 12. So.
Yeah. So you ended up taking a rate and a time in a roundabout. Yeah, you did the same thing I did. I'll come back to that. Did anybody else get 4.8? 4.8 hours? It actually comes out to then 4 hours and 48 minutes if you break it down into minutes. Nobody else got 4.8. Not one person. Nothing? Let me try to share this. And again, I'm playing around with some new stuff here. So that my online students can see this better. Let's try this. Do you guys agree that work equals rate times time? Like the job that we're doing, if I take the rate of work times the amount of time that somebody works, that'll give us the amount of work that is done. So depending on how you set this up, if how much work is there to be done, I'm just going to call it one garage needs to be painted. Do we need to know the size of the garage? Big garage, little garage? Does it matter? Nope, not in our context, it doesn't. So that's a question you might need to ask yourself. Some of you might have been thinking, well, if I don't know the size of the garage, I can't do this. Okay, these are all things that are going to go through your head. So do you agree that, let's see, the rate of Jamie, we don't know what it is, but we know that it takes him 12 hours? Do you guys agree with that? I'm just writing things down to see if something clicks. Okay, that's the other thing. If you stare at a blank piece of paper, might not get anywhere. If you just start writing things down, even if you're writing things down that are worthless and you don't even end up using it, nothing hurt, right? No harm. Sometimes things will click. If Karen painted one garage, if I said the rate of Karen, it would take her 8 hours, right? So what is RJ, rate of Jamie? Can we calculate that? Could I come up with an answer for RJ? Divide both sides by 12. So the rate of Jamie is 1 divided by 12. What's the label on that number? 1/12 what? One-twelfth of a... Nope. 1 is a garage. 12 is an hour. So I can do 1/12 of a garage per hour. I can paint 1/12 of a garage per hour, right? If I work for 2 hours, I'll be 2/12 done. 3 hours, I'll be 3/12 done, and so forth. Karen can paint how much of a garage per hour? 1/8 per hour. So what happens if the two of us are working together? If the two of us are working together, then what's our rate together? What would we do? Couldn't I just say the rate, I'll go RT, rate together equals 1/12 plus 1/8? And if I add those together, that's actually 2/24 plus, getting a common denominator here, plus 3/24 gives me a total of 5/24. So I would say together our rate is 5/24 of a garage per hour. You guys okay with that? Together we can do 5/24 of a garage per hour. So if I say one job, one garage is equal to rate times time. The rate is 5/24 of a garage, and the time, I don't know what the time is. That's what we're trying to find out, right? How do I solve for t? Take both sides times 24/5, and I'm done. So t equals 24/5, and if you divide 24 by 5, you get 4.8, just like Luke said. It'll take 4.8 hours to do it together. Now, could you have solved that a completely different way? Sure. There's a lot of different ways to look at it. You can draw a picture. You could draw a picture of a garage and start shading it and count boxes. There's all kinds of different ways to look at that. When I do something, I tend to think algebraically. I tend to think, well, I need to set up an equation and I need to solve that equation. And this is algebra class, so that makes sense, right? So, again, I don't want to spend all day on this problem. I want to get to other problems, and I understand some of you are like, oh my gosh, this is terrible. We need to get better. If you were completely lost on that, let's keep practicing some more. Let's get better at writing things down, setting things up, trying things. It's okay to fail. Talk to somebody else, come up with ideas, and we'll tackle something. I'll give you one here that isn't too bad. Let me plug in my audio. This is going to involve watching a video. Everybody ready?
We will
now begin awarding the Master of Laws degrees. Mariam Abai. Bakhtiar Abdulhamidar. Anish Agarwal. Monica Francis Aguinaldo. Olufunileo Ayoka Akinosi.
What's going on here?
People for graduation.
Say it again. They're announcing people for graduation. Yes. We've all sat through a graduation before. Okay. Have you ever gone to your cousin's graduation? Or your relatives or your brothers or your sister's graduation? Anybody? Have you ever gone to a graduation simply because one person was graduating that you knew and you didn't know anybody else there? So what's going on with this guy sitting at graduation?
Trying to figure out how long it is till his cousin graduates.
Right. He probably showed up to hear and watch his cousin walk across the stage, right? So what's the question? Katie already kind of said it. What's the question we're interested in here? How long is it going to take before we get to my cousin? Because I don't care about the rest of these people. Do you guys see where we're going with that? Okay. Let's. I'm going to, with that question in mind. Okay. How long is it going to take to get to my cousin? Like let's say that's you, and you're waiting for your cousin to walk across the stage, and you want to take a nap. And you want to take a nap, but you got to know I'm going to set the alarm on my cell phone to wake myself up so I don't miss my cousin. Okay. With that question in mind, try to start thinking about how you would solve this and what further questions might you have. We'll watch it again.
We will now begin awarding the Master of Laws degrees. Mariam Abai. Bakhtiar Abdulhamidar. Anish Agarwal. Monica Francis Aguinaldo. Olufunileo Ayoka Akinosi.
Okay. Does anybody have an idea? Does anybody desire more information? Floor is open.
How many names are there total?
How many names are there total? Is that a pertinent thing to know? Yeah, were you guys able to count it as it shuffled by? No. I think I might know that for you. Let me double check to see if I have the answer to that. There are a total of 167 names. Our cousin that we're interested in is the 156th name. The 156th name. 156. Okay, before we go any further, what I'd like you to do is I'd like you to take a stab at what you think is the answer. Total guess. Total guess. How long is it going to take to get there? How long is it going to take to get there?
minutes.
18.2 minutes. You don't have to give me your guess. Here's what I'd like you to do. come up with a guess that you know is way too short of time and a guess that you know is way too large of a time. So, but be brave. Obviously, it's not going to happen in 3 seconds. That would be a not taking a risk at all. And obviously, it's going to happen within 72 hours. That would also not be a risk. Okay? Give me an answer that you think is too small. Give me an answer that you think is too big. You have 6 seconds to figure out your range. Write it down on your piece of paper. A too small answer and a too big answer. Okay. What's your too small answer?
10 minutes.
10 minutes. Does anybody have, for their too small answer, does anybody have more than 10 minutes? What do you got?
20.
More than 20? Anybody got more than, this is for the too small answer. What do you got?
37.
37 minutes? Anybody larger than 37 minutes? So 37 is our largest too small answer. Now let's go to the too big answer. What's your too big answer? 1 hour 30 minutes. Anybody less than an hour 30? 50 minutes. Anybody less than 50? 40. Uh-oh. See a problem coming on here? Anybody less than 40 for the too big?
20.
20 is too much? You think it's going to happen before 20 minutes? Is that what you're saying? So we already have a problem, don't we? One of our too small answers is actually bigger than one of our too big answers. So we've got an unbelievable range going on here. Obviously somebody's wrong, right? Because you're saying it's absolutely going to happen in under 20, and you're saying it's absolutely going to happen after 37. Okay? Now write down your just right answer. The one that you just think it is. If you were trying to nail it right to the second, write it down on your piece of paper. Circle it. You got to have it written down, because when we reveal the answer later, you can't say, oh yeah, I had that. And then there's no evidence of you actually having it. Everybody got their guess written down? Okay. Any other pieces of information or questions that you might have before you try to start tackling this?
Is there any breaks between?
There is no break. She basically just rattles off the names nonstop. Good question. Any other questions?
Mariam Abadi.
I'm going to let this run. It's 3.5 minutes long. Now it's not going to get all the way to the end. But as this is running, you go ahead and try to start coming up with your solving process. Figure out what you're going to do. If you want to work with a neighbor, you can. If you want to work individually, you can.
Monica Francis Aguinaldo.
You can use your computer if you want. You can do it with a calculator, paper and pencil, whatever you want.
Adiva Monica Acuno. Sarah L. Logan. Rosanna Plata. Pradeep Arjan Singh. Alexei Atamanov. Estina Al. Adelaida Bagdasarian.
If you want to see the list of all the names, there's a PDF on Blackboard under Course Docs and Links. You can see the entire roster of all the people. Okay? That's on Blackboard.
Mauricio Becerra. Lucas Vilas. Opayami Mensa Felix Bello. Jared Gordon Biden.
So what we're looking for now is what is this clock going to say
Alex Spober.
right when she says my cousin's name? That's what we're trying to figure out.
Michele Boggiani. Fatima Bakari. Jasper Boyser. Hector Cardenas Ortega. Elizabeth Mary Carthy. Smriti Chandrasekhar.
Does anybody want to see the first video again? Does anybody want to watch this video again? Or do you have what you need?
Chen Yingru. Spaniso Simani.
Flag me down when you have an answer
Rebecca Kramars Cohen.
and be prepared to explain. Get to work. You got an answer?
Antoine Constantine.
Hang on 1 second. What you got?
15.6.
Okay, and can you explain that?
It takes her about 10 seconds to go through one person's name. So I just basically
Okay.
did-
Good rationale. Good rationale.
This is what I got.
Is that in minutes?
Yes.
Okay. Why? How did you do it?
It takes about like 8 seconds for
Mm-hmm.
her to call a name. So I did it by how many people till she gets there, and then I divided it by a minute.
Okay. To get minutes. Okay. Anybody else? Okay. And what makes you think it's going to be that?
Takes between 9 and 10 seconds for each person for her to say each name. And if we want to get to the cousin, then it'd be 156 people. And then you divide by 60 to get the minute.
Okay. I like some of your rationale. I feel like some of you are getting a little loose with how long you think it actually takes in between people. What do you got?
Don't have it.
Not ready to share yet? Anybody else? What do you got?
This,
Okay, tell me how you got that.
it takes 5 seconds per person,
Mm-hmm.
and you figure out how much is in a minute, so 12, and then
Mm-hmm.
just divide by that.
Mm-hmm. So, everybody I've talked to thus far has an idea of how long they think it takes in between people. However, some of you have said, well, it's about 5 seconds in between names. But then somebody else said, well, it's about 10 seconds in between names. Yee. It can't be both 5 and 10. That's a big difference. Do you guys agree? If you think it's 5 seconds and somebody else thinks it's 10 seconds, then you two need to talk about your range. That's what, so standard number 6 says, attend to precision. Sometimes when we're doing something, the difference between 5 seconds and 10 seconds is negligible. Okay? Like, let's say we were all going to drive to Minneapolis after class. And we said, how long is it going to take? And one person said sometime and another person said one time, and we were 5 seconds apart. Does that really matter? No, because we're driving to Minneapolis. It's going to take us 5 hours anyways. What's the difference between an additional 5 seconds? Okay? So if we're within 5 to 10 seconds on driving to Minneapolis, I would say we've done really well at attending to precision. We were really precise if we can get it within 5 or 10 seconds, right? If you think the gap in between her reading the names is 5 seconds and somebody else thinks it's 10 seconds, that is not precise. Do you see the difference? Because here a 5 second gap is huge in the grand scheme of what we're trying to figure out, right? So that's what I mean by attending to precision. So what I'm going to do is I'm just going to back this up again. And you tell me about how long it takes in between people.
Mariam Abadi. Bakhtiar Abdulhamidov. Anish Agarwal. Monica Francis Aguinaldo. Olufuleo Ayoka Akinosi. Godiva Monica Akulo.
Anybody changing their tune just a little bit after you watch closer?
Sarah Almogren. Rosanna Plata. Pradeep Arjan Singh.
I'll give you another minute to do some calculations. We'll share the answer in a little bit here.
Alexei Akramonov.
Ask yourself if you're being precise. Ask yourself if you've taken into consideration all of the variables that are at play here.
Adelaida Bagdasarian. Peter Robertson Barnett. Solongu Bayasaikan. Maurizio Becerra.
So far I've seen a couple answers that are really darn close. Anybody want to share? What do you got? Say again. 14 right on the nose? Around there? How'd you get that?
Well, then I like 5 seconds and then you divide it and it's like right now 14. I was like, well, maybe it'd add seconds for like if it's a longer, if one person takes longer, then someone else will take shorter.
Some people have shorter names and some people have longer names. Okay. Good thinking. Anybody else? Okay. Based on what?
So it took about 45 seconds to get 5 names done. So it took 5 names divided by that.
So you're saying 45 to do 5, so it averages 9 per name. Okay.
Elizabeth Mary Carthy.
Aaron just loves pizza.
Is the camera looking at you guys all the time?
Yeah.
Yes. Yep.
The entire video.
No, the entire video is just going to be you guys here. If I move it over here, it might catch me a little bit better. Okay. I know the anticipation is killing you. The people I talked to all had good rationale. I think the answer is this because of this. Okay, so that was pretty good. There was some good thinking going on there. I'm going to pull up the actual answer. Here we go. Let's see how close we can get. Don't worry, we're not going to watch the whole thing. They'll fast forward a little bit. Yeah, exactly. Do you guys remember the cousin's name?
Anash Ragis.
17 minutes and 12 seconds about, right? I think it was about 17:12. Let me go back. Here it comes. 17:12, right? Okay. Who thinks they were close to 17:12? What would you have?
I had 18.2, so I got the ending time.
You got 18. Oh, so you got the end, not the cousin time. Anybody closer than 18.2? 17:12 is our winner here. Anybody closer than 18.2 is a minute off. Nobody? Going once? Going twice? Okay, not bad. You don't win anything. Sorry, Katie. You win pride. I'm gonna show you how I went about solving this. And again, just because I solve it one way doesn't mean you had to necessarily solve it the way that I did. So, first of all, I gave you guys this information, but I went through that roster and I counted up all the names, and I figured out that my cousin is number 156. So that just took a counting, right? That just took a little bit of time. So the cousin is number 156. So now I'm thinking, maybe I'm just going to write down that the first person got announced at 15 seconds, the second person at 22, the third person at 28, and so forth and so forth. See what I'm doing here? Person, comma, number of seconds. And if I take all that data, I just stopped after 17 people. I used my computer and I just punched it in. I think this is actually different. I did a bunch of one person, 15 seconds, two person, 20, whatever. I punched it all in, and I basically found out that it's going to roughly model a line. Do you guys agree that this is just going to be linear? It should be linear. What would cause it to not be a straight line? If our announcing person did what? Paused, would screw it up. What else would screw it up?
If you said her name really fast.
Yeah, if what happens if she just started picking up the pace and going super fast? Or vice versa, what happens if she really, really slowed down? Then it wouldn't hold true to be a straight line anymore, would it? But it's pretty darn close to a straight line. You can see she deviated a little bit there, but got back on it. So notice if I blow up my font size here, do you guys see the equation of the line that I produced? This blue line at the very bottom of the screen? Y equals mx plus b. What's my m? 6.75. What's the label on that? 6.75 what? Seconds per person. Yeah. Now, Taya, you made a good point earlier. Share that, what you told me.
Oh, I said I thought about adding time for if people have long names, so pauses. But then I said other times it'll be going quicker and it'll be shorter names. So.
Right. Like the one person had 6 names. Okay, and it took 4 seconds just for her to read the name, right? But other people, they can read the name really fast. So do you agree that's going to throw it off a little bit? I told you before we started, I knew nobody was going to nail it right on 17 minutes and 12 seconds. Do you see all the things that are, all the potential sources of error that aren't going to allow us to calculate this thing right to the second? But if I go back to the painting example, that's what we call a contrived problem. That was set up to say it takes Jamie 12 hours to paint a garage. Not 11 hours and 59 minutes, 12 hours. You see how some problems are just contrived? They're kind of easier than the real life problem is. This is more of a real life problem, and it has all sorts of error in it. So you need to think about things that would contribute to that. So it's roughly 6.75 seconds per name, or I came out with 6.74, whatever. I punch in my cousin at 156, and I calculated 17 minutes and 41 seconds. Was I correct? Right. Like I said, I didn't expect to get it right on. It took 17 minutes and 12 seconds. Is there any way we know how fast or slow she went in the 12 minutes of video that we couldn't see? Of course not. It's a guess. It's an estimated guess. So that was just an example of a linear relationship. Let me give you one to watch. And this is going to be the one that I want you to figure out for Monday. Okay? So I'm going to go back to Blackboard. Underneath the Harvard graduation, there is the escalator video, but I got to show you this first because I just saw this the other day. Did you guys catch this video? Guys ever been on one of those airport walkways? Apparently this lady's never been on one of those airport walkways before.
It's a workout. Let's go.
The worst.
Okay. Okay, so on a related note, here's a video to watch.
This is tricky. Oh, you're gonna
You guys know where he's going now.
School.
What's the question I'm going to have you try to figure out for next time? Why would you do this? Because it's fun. So we've conquered that question. Any other questions? How long is it going to take him to get to the top? Okay. Now, this video is available on Blackboard. It's escalator video number 1. See that? You can watch that 1,000,000 times. Okay? That is the only piece of information, that video, that's all you get. Okay? The question that you're trying to figure out is, if we were to let the video run, how long is it going to take him to get to the top when he's going against the escalator? How long is it going to take? Okay, come back with an answer on Monday. See you then.
You got my pencil? Yeah.